Alright, let's look at another example of an improper integral. This time, integral from 1 to 5 of 1 over x minus 2 to the 1/3 dx. So, you don't want to take the antiderivative and plug in the bounds because this function is not continuous on this interval. You can see right away that x cannot be 2, so we have to break this into a sum of two integrals and use limits to evaluate the integral. So the difference in this problem is that your discontinuity is not at an edge point. It is directly inside the interval, but that's okay. So we'll break this into two integrals. The integral from 1 to 2. I'm just going to go ahead and rewrite this off the bat as x minus 2 to the negative 1/3 dx plus the integral from 2 to 5 of x minus 2 to the negative 1/3 dx. So I just broke it up at the discontinuity. You can do this multiple times if you have multiple discontinuities. Now we're going to treat this as a limit problem, so we'll say the limit as something like b goes to 2 on the left, the integral from 1 to b, x minus 2 to the negative 1/3 dx, plus the limit b goes to 2 from the right, integral b to 5, x minus 2 to the negative 1/3 dx. All we did was swap out the discontinuities with limits. The rest of it is the same. So take the antiderivative. We're going to get to x minus 2. Add 1 to the exponent, which is 2/3. Divide by that, which is the same thing as multiplying by 3/2. And that's from 1 to b. We'll have the limit of that, plus the limit as b approaches to the right. Same functions, the same antiderivative, 3/2 x minus 2 to the 2/3, evaluated now from b to 5. Okay. Put these limits for a bit. 3/2, and now we just plug in our bounds as you would expect. So b minus 2 to the 2/3 minus 1 minus 2 to the 2/3. That takes care of the first integral, plus the limit as b approaches 2 from the right, and same thing here. Three-halves. Plug in the upper bound first, 5 minus 2 to the 2/3 minus b minus 2, also to the 2/3. And that's where we're at so far. Now we can take our limits. 3/2. Now as b approaches 2 of this function, or this term, b just gets 0. So we get 0 to the 2/3 is just 0, minus 1 minus 2 is negative 1 to the 2/3. Okay. And we're going to take the limit on this one, 3/2. 5 minus 2 is 3 to the 2/3, minus, again you plug in b equals 2 and you get 0. We'll factor out this 3/2 from both of these terms. Okay, so negative 1 to the negative 1 squared is positive 1, and then positive 1 to the 1/3 is just 1. So this is negative 1 here. plus this is just 3 to the 2/3. There's not much we can do with that. So it looks like our final answer is just 3/2 times -1 plus 3 to the 2/3. And so because our integral is approaching a number, we say our integral converges. And of course it converges to this number.